Today we will be looking at concepts to graph equations. So this is Chapter 2, Section 8, Part 1. Tomorrow in Part 2 we will actually be graphing the equations. So let's take a look at the first set of directions. It says use the given x values to write solutions for each equation as ordered pairs. And so what we're going to do is they're giving us this equation here. And so y equals, and then this is the function, 5x plus 3. So this changes the x value and it comes up with a y value. So what we're going to do this is we're going to make a little chart. We've got our x values, and then we're going to end up putting those into this function fx plus 3. And then this is going to give us a y value, and then from there we can do what they're asking us to do, which is write an ordered pair. So ordered pairs are x and y values combined together as one, so you can see them, that we can end up graphing them on a coordinate plane. So let's start with this first one here. We're going to go ahead and put in the value of 1. And so when I put in the value of 1, I'm putting it in for x here, and then I'm going to do some operations. So I got 5 times by 1. So what is 5 times by 1? That's 5. 5 plus 3, what does that make? Well, 5 plus 3 makes 8. So what I can do is I can write that as an ordered pair. So it's 1, comma, 8. So let's take a look at the next one. So they want us now to put in x as 2. So we'll go ahead and do that. So I put the 2 in place of x. Now, in place of this x in the function, I'm going to write the number 2. So before I wrote 1, because that's what I put in place of x, now I'm going to write times by 2. So do that in your head. 5 times 2 is 10, and then add 3. And so when you do that, you end up at 13. And so that's 2, comma, 13. Let's try the next one. So now we're going to take the 3 and put that in for x. Now we substitute that 3 in for x into our function. 5 times by 3 plus 3. Well, 5 times by 3 is 15. 15 and 3 gives me 18. And that makes 3, comma, 18. Now I want you to notice something about these numbers here, these y values. So notice what they're going up by each time. See, they're going up by the value that is being multiplied by x. See, 8 plus 5 makes 13. 13 plus 5 makes 18. And so if you notice that, that's what's changing x each time. See, this positive 3 is just a starting point. It gives us somewhere to start when x is 0. But then from there, it's the 5 that changes x each time. That's a big concept that we'll be seeing later on. So let's take a look at the next one. So we have a new function, negative 4 times x gives a value of y. So we've got different values here. Now, you're not going to see that same correlation we did with these y's, because here the x's were going up by 1. And so we saw the correlation here. Here the x's are going up by 2. So we're going to see something a little bit different. So let's go ahead and set up our chart. So we've got our x values. We've got our function of negative 4x. And then we'll have our outputs, our y values. And you can think of it that way. These x values are inputs. We're inputting a 3. We're inputting a 5. We're inputting a 7. And then we're going to be getting these outputs. And these are the y values. Once we get those outputs, then we can write the answer as an ordered pair. It gives us a way to graph those values. So let's go ahead and substitute. So we're going to take that 3 and put it in for x. So it's negative 4 times by 3. Well, that gives me negative 12. So my answer, my ordered pair, is 3, comma, negative 12. Now look at the next one. Negative 4 times by 5. Well, that gives me negative 20. And so I'd write down 5, negative 20. And the next one, put the 7 in place of x, so it's negative 4 times by 7. So that makes negative 28. So I'd write the answer as 7, negative 28. Well, let's just take a look at those y values. As I said before, notice again here, the y values were going up by 5 each time. 8 plus 5 made 13. 13 plus 5 made 18. And you notice that the number in front of the x, what's changing x each time, was 5. Here, the numbers are going up by 8. Negative 12 and then actually down. They're not going up, they're going down by 8. So they're going taking away 8. Well, the reason is that we are skipping numbers here. If we had a 4 and if we had a 6, we'd see it being going down by 4 each time. But here we're going up by 2, so our x or y values are going down by 8. Notice that's double what our coefficient of the x value is. Let's move on to the next type of problem. It says determine whether each ordered pair is a solution. A solution, that means that it equals the given equation. So that means when we take our value of x, we take the value of y, and we substitute into the equation here, we should get an equal value. So 6 is x and 4 is y. So 4 equals 2 times by 6 minus 8. So we perform order of operation, bring down the 4. This makes 12. 12 minus 8 is 4. So those equal. So when they equal, then we say yes, that is a solution. Let's try the next one. Here we have 8 for x. Y is 72. So we put 72 in for y equals 8 divided by 9. Well, 8 divided by 9 is a fraction. It makes 0.8 repeated. And so that is not the same thing as 72. So those are not equal. So we would say no. So you can definitely see how 8/9 is not the same as 72. Let's take a look at our next one. Again, here's our x. X always comes first, then y. The reason they do that is they call them ordered pairs. And ordered pairs go in alphabetical order. X comes before y in the alphabet, just as the -3 here, the first coordinate, comes before the second coordinate. So we go ahead and substitute in. -18 equals -6 times by -3. Well, it just about makes it, but negative times a negative makes a positive. So this would be positive 18, not negative 18. So this is another no. Let's take a look at our last one here. Again, our x value or y value, so we substitute. So we got 64 equals 12 times by 5 plus 4. Well, if you remember your 12s, you'd know that 12 times by 5 makes 60. 60 plus 4 should equal 64, and sure enough it does. They do equal. So when they equal, that's when you say yes, that point is a solution. Well, the last set of directions asks us to find the given value of y for each given value of x. So we're supposed to use this graph, or this linear equation. Linear has the word line in it, and that's what it is. A linear just means that it is a line that we have drawn. It does not curve, it does not V, it does not make a U shape, it's a straight line. And so that's what we have here. And so what we're trying to do is we're given an x value, so x is 2. Now we want to go and find out what the corresponding y value is. So you see how I go over 2 and then up to the line, and it stops right there. So this x value at 2, see x is at positive 2, I went up 4 spaces. See 4 spaces there in the y direction. So that means y equals 4. Let's try another one there. Next one says x equals 1. So 1 is right in between 0 and 2. So here's where 1 is. So I'm at 1. Now I go up to the graph. See how it touches right at that point right there? That is 2 spaces up. So that means y equals 2 when x is 1. And so I try the next one. See here, x is 0. So there's 0, and it crosses right at that point. So that is y equals 0 as well. So when x is 0, y is also 0. Taking a look at our next one. X at -1. So now we're going to the left. This is the negative x direction. So notice I go left 1, I'm at -1. So -1 right here. And then I go down to the line, I end up right here. And this is the negative y direction. So that's -2. So y equals -2. One last one here. It shows x at -2. So going to the left -2, I go down 1, 2, 3, 4 spaces. So I end up at -4. So when x is -2, y is -4. Well, those are the types of problems you're going to see on tonight's homework.